Number 35. A car dealership has 41 cars for sale. The least expensive car costs $11,999 and the most expensive car costs $19,499. Another car priced at $33,499 is added to the dealership's inventory. Select whether the value of each statistic for the prices of the cars increases, decreases, or cannot be determined. Okay, so when I see a problem like this, I'm kind of visualizing in my head a dot plot. So here's the smallest one. This is, let's call this 11,999, and this is 19,499, and there's 41 cars, so there's a bunch of cars in here, many cars in my dot plot. Not the neatest dot plot ever. I'm just trying to kind of visualize this for you. So here's all those 41 cars in there. What's going to happen if we add a car that costs $33,499, this outlier here? The mean will definitely increase because the mean is the average. We add all these values up and divide by the number, so when you get a higher one, it definitely increases the mean. The median can't be determined. The reason it can't be determined is we don't know which of these data points is the median. In fact, we just made up these data points. If it's like a point like this here, then when this is added, it's just going to kind of bump up onto the same value. Or if it's, say, this is the median here, when we add this point in, it's going to bump it over to here. So it would increase in some cases, and in other cases, it would stay the same. So without knowing the specific data points, this cannot be determined. Standard deviation is a measurement of how spread out the data is around the mean. This data is tighter without this data point, right? It's closer together. It's not as spread out. When you add this data point, you're spreading the data out more. So this is an increase.